Next up, we have Vlatko Kosturjak with Application Container Security. Thank you.
Thank you. Hi. I will talk about application container security. What I will talk is about different implementations, but it's hard to cover everything, and it's hard to cover it systematically on some kind of academic level, whatever you have. And there is also like large organizations, they have their own implementation of application containers and so on and so on. So it's really very wide topic. So I will tell you mostly about some of my experiences, some of what I've done here, and from my viewpoint, how you can actually make it more secure. Let's go. Probably it will take 60 minutes. It depends about your questions and everything, so maybe we will finish earlier. About me, I'm consultant, typical security infosec consultant, working in Vlatko. By the way, we are hiring, so if you're interested, talk with me. I developed a lot of different code in different open source packages. I developed my own and so on, and I work mostly where I try to help secure like DevOps things with different clients, and I have experience mostly with Docker and LXD. So, in short, I actually talked a bit about this application security. It was like 3 years ago, and I only like touched Docker as part of DevOps because I talked a lot about other problems in DevOps. So I will talk mostly about what have changed since then, and if you're interested more about what I talked last time, there is like YouTube video of my last lecture that was 3 years ago, so you can take a look. And because what's the problem? Like 3 years old vulnerability is still vulnerability, right? So you still need to do your homework, right? So let's start. Is anyone familiar here with application containers and what they are? How many? Okay, most of you are. So for those who didn't raise the hand, I will just go quickly. So that means they are mostly like virtualization application level, let's call it that way. In short, that means you have same kernel, but you have several applications with some kind of isolation between them, right? And how it looks like graphically, I just taken that graphics from the YouTube video. It's actually, you have, when you're comparing with virtualization, you have like one layer less, and that means you can take much more resources, you can take advantage of much more resources between those applications. So if you're having like application inside virtualization, you're wasting time in different like virtualization machines, you're wasting your resources on like having much more kernels and so on, and in data centers, of course, that's a bit problematic, right? For the cost of virtualization itself, you are really like wasting some of the resources, and from the data center perspective, that's not good, especially once you have like thousands of virtual machines, or in this case, containers, right? The problem here is actually isolation is not at that good level as VM. There is also like talks where they say, oh, it's same and so on, but usually you have much more layers here in isolation, virtualization than in Docker containers. So in short, you can really run, like if you can run on your laptop like 3 virtual machines, probably you can like run like 10 or 20 application containers, because it doesn't take so much resources, in short. Just to have like a broad idea why you want to have containers and not virtual machines, right? The first thing I want to talk about is privilege of containers. Why? Because I want to talk mostly about like unprivileged default containers. If you are just using like privileged containers, there's no like any point, right? anybody can escape from it. Why? Because you are talking, if you are root at the container level, you're actually talking to the kernel with the root level. So you have like many options how to actually gain root from there, right? So it's usually like escaping from chroot, right? You have really many options, and from the defense point of view, you have to like implement like, I don't know, AppArmor or Cell Linux or whatever to actually defend it, and you always forget something and so on and so on. So it really, you don't want to have it like privileged containers inside if you're talking about security isolation between those containers. And another thing is, I will not talk too much about Spectre Meltdown because, yeah, it's affected, right? If even virtual machines are affected, so yeah, containers are also affected. There will be like two good talks, one after me. Frank would talk about this one, so there's no really point like repeating each other and so on. And there is Marion who talked yesterday, who actually also talked about this problem as well. So yeah, if you are vulnerable to Spectre and Meltdown, you will have problem inside containers. Escaping is also possible, and so on, and even from the unprivileged container. So yeah, that's how it goes. In short, you have to watch out on these things first, and then we can talk about this escaping from the unprivileged containers. Let's start with LXD. LXD is actually like canonical product for application containers. It's really tightly coupled with Linux, and you don't have for any other platform, right? Whoever have some kind of containerization solution. So in short, if you see that there is some kind of LXD for other platforms, that usually means that you have like client which is actually just talking with some kind of container control framework, which is actually on some other machine which is running Linux, right? So it's really like Linux only from where you are running your containers. Yeah, it's standard thing. You can like launch images, list containers, run commands inside container and so on, and make your own containers and so on. Problem actually, if you're looking at such container, usually once you run any standard container inside LXD, you will get like this list of processes, and you will see a lot of those. And if you are into any like microservices and so on, you will see and say, oh, it's so much services. Usually it should be like one or two, right? So looking from the LXD perspective, it's not so much about the paradigm shift like microservices and so on, but it's more like saving resources for some kind of, you get some kind of isolation, and you save some kind of resources on that side, right? And if you run like any command on LXD, they just made it to look much more like virtualization than containerization, right, of the processes. One of the examples is uptime, right? Once you launch in LXD some kind of container, it will look like it's just started right now, and if you launch it from the Docker, it will say, oh, you will get the uptime from the host. So these are the things actually just to give you a feeling. So if you just want to have some kind of much more resources to have, and on the other hand you don't want to so much change your paradigm of virtualization, then probably you will want to use LXD. And it's not so popular as other container solutions, of course. How it actually, for example, this uptime problem, actually uptime feature they actually just implemented Fuse file system where they actually put in proc uptime. They just put some kind of information when the container started. So everything looks like virtual machine. And you have a lot of processes. Even anybody who like started looking at the Docker and everything, they said, oh, don't run SSHD, and you will see it's running like SSHD by default here, and so on and so on. So it's really like virtualization with less resources, looking from that architectural point of view, right? So we will not spend so much time on this one because, yeah, it's typical like C groups implementation with namespace isolation and so on, but we will talk much more about this one. We will talk about Docker because it's much more popular, right? Anyone using Docker right now? Okay, in production? Oh, we have like 4 or 5 people. Okay. So I guess you already know it's same thing as with LXD. It's application container solution, but it's much more about paradigm shift, about microservices and so on. And it have like implementation where they have like abstraction levels and so on. So actually Docker is using lib container for everything regarding these ones. And so he talks to the kernel and so on, right? And of course, on the end, once you are using right driver, you are actually using on Linux, you are using C groups, right? And namespaces. In short, that means that your process, once you are running inside container, it have its own network stack, process space, and namespace. If you never used like Docker, you can look like images. If you're a programmer, you can think of it about objects, right? You just actually, if you're looking at the containers, you can think about objects, and if you're looking at the images, you think of the classes, right? Once you instant your class, you have the object, right? And then you can actually do something inside that one, right? You have the data inside. Since you are already familiar with so much about containers, I guess this will be enough so we can go further, right? You can also find like a lot of hosting, cloud hosting for Docker and so on, and you can like do all those things with the container. I know, list running containers, list local images, download images, and so on. But from the perspective of, from the defensive point of view, they're actually, since Docker is using layered file system, it can help you once, for example, your container is compromised. So, for example, I can just show you one of the examples, why it's quite useful. For example, let's run one of the containers, right? I'm just running a new instance of container, or maybe I can just, I hope you can see it, right? Let's run Debian inside, and we will run like bash inside that container, right? And you will see it's running inside, right? You have only like single process, which is that one process which I have, right? It's bash. So, for example, let's say that evil attacker attacked my like application or whatever. He got like the serialization issue, what Tony Weir talked, or I don't know, SQL injection or whatever. And then your container got compromised, right? So let's say some typical, right? Let's write quickly. Maybe you can help me how a typical shell looks like, right? Is this one good one? Do I have any syntax errors? Well, we will not run it. It doesn't matter, right? well, let's call it shell PHP. It will be so obvious. But anyway, you will see it here, right? And I see something is happening, right? From my perspective, I could just run like, from defensive point of view, right? I can just run like diff. It's similar like workflow, like if you're using like Git, right? And you get everything what changed on the file system from the original image, right? Idea here is actually to have everything what's code and everything inside the image, and you're just running like temporary files inside the container, right? And you're running volumes for any permanent data, or you are just storing somewhere else, right? So here you can actually see that new files, and you can immediately know what's changed, and then you can of course do better incident response than on normal system, right? So yeah, you can start run container and whatever, right? I guess you know. The only problem which I want to emphasize is that your container, of course, depends about a lot of things. Well, we mentioned some of them already, like spectrum meltdown, because yeah, it depends on hardware, operating system, and so on. The problem is that it only needs one item to fail to actually fail everything, right? In most cases. Depends how you are good at layering your security controls. So let's go actually how you can actually build those images, right? There is actually two ways. One way is actually to have Docker file. Probably who use Docker knows that you can just, I don't know, write from which image you want to base one, and then you just run commands how your image will look like. The other thing is actually you can build it manually with commands. I don't know, you can change the container, what I've done here, right? And I can write something like docker commit and then say something like, oh, I have deb one and this one will be Debian mine, right? And this one will immediately become the image. The problem is now, of course, I have shell inside the image, right? So there are actually two ways. The first one is better one, and usually people mostly using this one because you're actually documenting how you deploy your application in some other way, right? And this line is actually one of the layer file systems, right? For every this command, and that's why you see there are a lot of in Dockerfile, lot of end-to-end, because you want to flatten your layers inside the container. So you can actually get the smaller container once you have your image, right? So there are two ways. Of course, there's a lot of, now in DevOps you have a lot of those, just run this command and then we will install everything and that's it, right? I guess you heard for that curl pipe delay proof of concept where you can actually get some command executed and how, depending on how it detects the timings and everything, so you will get different output if you run manually curl or if you're running automatically. So this can get used to actually execute some commands. So definitely, if at least you are doing something like this, it should be good to use HTTPS because of like man in the middle, right? These are just the basics, right? We will touch the, let's say it, we'll go a bit deeper later. There is also like things, how you can actually build it, right? First one, you have one image, right? You have like Docker file and how you build it. You can build it on your machine, or you can actually upload it or put it somewhere like GitHub or whatever, or Bitbucket or something. And then you can actually say like create automated build, and then you can have it on like cloud repository which Docker have, and then it will like build it out automatically itself, right? But in short, that means if you can run commands on that one, on cloud repository of Docker, that in short means you can actually run whatever you want on that machine, which is building machine, right? So you can actually run any commands on there, and it's actually free computing resources for that time, how much you can build. And these are the limits, right? You can take this machine for 2 hours, and you have this CPU and so on. So I call it like a free computing resources, and you can, I don't know, use it for cracking passwords or scanning or whatever, right? In those limits which are there, right? It's completely free. If you look from the security point of view, yeah, it comes with reasonable security settings, but not by default. You have to turn some things on to actually be hardened, right? Every container, I'm talking about unprivileged containers, is running with a reduced number of capabilities. And if you turn on everything what should be there, actually you can get much better security. I will tell you which, from my standpoint of view, are actually good options to turn on. You can, of course, add much more like capabilities and so on if you need it, but by default it's really like a reasonable capabilities which are turned on. For example, you don't have like ptrace capability by default, so not so easy to escape. Other thing is Docker in the meantime implemented like user namespaces. So that means if you are inside container root, you are not actually root from the host point of view to the kernel. You're not talking to the kernel with this one. How it works actually, it's standard like namespaces where you actually inside, for example, with 0 root, but you are talking actually to the kernel as some very high with. That means it's much harder to actually escape from this container than usual, right? It's typical like user namespaces. This is something that you want to turn on if it's not turned on by default. Another thing which actually helps, and it's implemented in Docker 1.10, it's syscall filtering. So if you know how your application works and you know which syscalls you are using, you can just like typical, you can implement typical seccomp profiles, and you can actually say, oh, I just want for this container to run only these syscalls, and then any like exploitation is much harder than usual. So you can actually like, I don't know, deny those syscalls, or you can log if you see something problematic and so on. It's quite good, so you can actually do additional hardening. Another thing which you should actually do inside like a Docker is actually when running Docker containers, Docker daemon, actually in production is if you don't need like communication between, like very open communication between containers, you can like turn on like inter-container communication, like ICC. You can put it to false, and then every container inside like network will not see each other. This is definitely good options if you don't need it. And once you actually define the links between, I will show you how you define the links. It will just only open with IP tables communication only on that ports between the containers. So this is one of the production options which are quite good to actually implement, right? Another thing is, which I actually mentioned like three years ago, is that Docker control is actually done through the socket. It's by default, and it's reasonable security by default. You only have a Unix socket to talk with Docker. And if you have permissions to talk with Docker, that in short means you have root on the host. So whoever have access to this file, it have root on the host. If you allow nobody to access this socket, you have root on the host. Not on the containers inside, but on the host. So that means if you expose it, you are owned on the host level. And I just implemented one of the proof of concept. It was like standard one, where how it actually works. Whoa, we have a lot of those. Whoa. How it actually works, it's actually you are just making a new container, but you are actually using like putting like root file system from the host. You are attaching to the container, and then you can actually write to everything inside container. And then since you are actually controlling Docker from the socket, you can actually do it, and then you have boom root on the host, right? You can write to shadow file or write to any other like cron D or whatever, and then you have root on the host, right? This is something I already talked 3 years ago, so I will not spend so much time. In short, that means you can just easily get the like remote code execution or actually remote shell, right? In short, what's here recommendation? Do not expose Docker API over network, or even not over network. If somebody have access to the file, to the socket, it's definitely problematic. If you have to expose it on the network, you still have to use like VPN or TLS certificates or whatever. And if you are having some kind of application for provisioning Docker containers and so on, definitely you want to filter untrusted input in your application to actually, that somebody cannot just send whatever he wants to the Docker socket, right? Or Docker API, whatever, right? This is standard recommendation, and you have it in documentation. Nothing new. The problem here, once we start with looking at the Docker images, is that you have problem of regular update of base OS utilities, application components inside application, and so on. And of course, once you have like that Docker image, once you are transferring to yourself or back to the repository wherever it is in the cloud or your local one, you have to have some kind of security that is not tampered or something in transit, or once you store it in storage that it doesn't have any problems, right? If you're looking at like images typo squatting, like oh, I just mistyped like Larry repository with 1R and so on, yeah, it's possible, but it's limited, right? So they actually limited, for example, characters, how you can actually name the repository. It's like 4 characters minimal. And I just wanted to, for example, I tried to register like a repository in the cloud, like HTTPS, but it said, hey, it's reserved for. But to me, it was a very nice name. And there were a lot of usernames already taken because a lot of people are using it. So it's kind of hard to actually do some really good typo squatting. Yeah? But it's, of course, it's still possible. Especially if you have some kind of usernames and so on. For the root ones, it's much harder. Yeah, and if you look what you can do from the images standpoint of view, you can look at the sysdocker benchmarks and you can see whatever you can harden it and so on. And from the networking, yeah, I already told you about ICC turning on. So if you look from the security standpoint, it's really similar to everything else. You should base your images on trusted images, and you should use user directive. What that means? That means that you're actually changing it from the root to something else. So if attacker actually gains some kind of privilege on your account, on your application inside container, it will actually be normal user. And once it's normal user, it will spend some time to actually get to the root, and from the root to the, I don't know, any host evasion, right? So privilege escalation to the host. In short, it's from security standpoint of view, it's like smaller image is smaller exposure, right? You want to have your image as small as it possible. So that's usual recommendation. Don't install packages you might need. Don't build with SSH daemon, because anyway you can like just run commands with docker exec. And don't build images everything from Ubuntu, right? Why? Because it's just big, and if it's bigger, of course you have bigger like exposure what can get used to actually gain some kind of privilege escalation. If it's like privilege escalation to root or privilege escalation to host, right? And you can actually go to the micro badger, and it will actually show you for any image you have, it will show you what layers are there and how big it is. It's similar to, for example, let's see. Let's run this one, right? So if you go, for example, and compare Ubuntu image, which is 30 megabytes, right? And if you go for some kind of other distribution, which is smaller, like Alpine, it's 2 megabytes, right? So it's much smaller. So definitely smaller surface to attack in this one. In short, probably you want to consider Debian is also much smaller image than Ubuntu itself, right? This is everything from the last time. What you want actually to implement in production is actually image building automation. Why? Because you want to update the images on regular time. If you are using it in production, you want to actually update images on daily basis, even if it's critical, maybe even more, depending on how quickly you get operating system updates and so on. So what that means, if you are using Debian, you want to have on daily basis like upget, update, upget, upgrade, and then you have to pull the image on regular basis and up the components and update the application itself. And there is actually automation for this, which actually watches every image you are using, and it will automatically update the images you are using from the repository you specify. So it will check if there is any new one, and if there is new one, it will automatically update. So you don't have to waste your time checking some boring system administration stuff, looking, oh, we have update, we will run it, and so on. So this watchtower is quite good if you're looking on automatically updating your containers. Another thing, by the way, I just want to show you also, if you're doing Docker login, that actually means, and it actually tells you, it will store your password in plain text. It's base 64 inside home.docker config file. You can actually find this one. So it's quite useful if you forget your password for any other use. It's quite problematic, right? So I will talk much more about Alpine as well. It's security-oriented distribution, and it's now mostly popular for building Docker images. And it's definitely one of the good examples how you can actually get very, very small image, right? For example, here I was using anyone here from the forensics point of view or incident response know for known file hashes, right? Where you can actually get the known file hashes and then compare them with what hashes you have, so you know which are changed. And you have a national repository of all those file hashes you have in installations and so on. So you can actually compare it quickly. And it's usually 2 gigabytes, that repository. And here, for example, I used different techniques and black magic called Bloom filters to actually reduce it to a very small number, under 100 megabytes. You have inside container every known hash, and you can actually ask if any hash is known or not known, so you can quickly actually go through the files and know which are compromised or not. And just to give you an idea how you can actually reduce the size, for example, you have Postgres, typical Postgres image. You have with Alpine is 26 megabytes, right? Oh, and with this one is with Ubuntu is 80, right? It's really much bigger with Ubuntu. So definitely you want to reduce the attack surface. But the problem, just like 2 months after I talked here on balcony, I actually found some problematic things in Alpine. Like easy privilege escalation. How easy? You actually just run the command, right? And you are nobody inside container, right? But if you just write su, you will immediately get root. It's really crazy, right? So, yeah, you are using user directive inside Docker file and everything, and you are like spend some time hardening and so on, and then somebody just writes su, it becomes root, right? It's quite problematic. Yeah, I reported it. It was like in November 2015. In September it was balcony, right? And they fixed it like 1 month later. The problem is, actually, they fixed it on the image, but that means that every image which was based on Alpine have to be updated. And there is like very, very old images, and every image should be updated. And there's like a lot of images which actually just doesn't update, right? So that's the problem. If you're using in productions, you should really update every layer of the Docker images, and then it will not be a problem. The other things is you shouldn't rely on tags. It's better to check like really if you can sue or not than to tags. Why I'm talking about this one? Let me just show this command, just to give you a little bit idea what's the problem. Let's say you have like those lot of Alpine images, right? Let me just make it. And you have like this one Alpine image, right, which say latest, right? And if you're just looking at the tags, whoa, this one is latest. I will use it and forget it, right? The problem is you have to pull it first, right? If you didn't do this, let me just show you. Oh, maybe this one will be. A little bigger, okay. So here are updated versions, right? You have to look at these ones. When last you updated this one, right? Here is 3 days ago, 3 days ago. And with this one, which wasn't updated for 2 years, it's a problem, right? So if I just run this one, of course, it will not work. And if I use tags like latest, and I didn't pull the latest image, oh, I'm root, right? Yeah, so don't rely on tags. And of course, another problem Alpine have, it's just like released 2 days ago, probably you saw it on Twitter. They have actually problem because they check the signature after the extraction of the packages, and they are transferring the packages over HTTP, so everybody can do the man in the middle and change the package, and then actually you can get remote code execution inside. So yeah, again, you have to update and pull and everything, right? Because it's fixed, and you have like blog post which tells everything about this one, right? It's this one, right? I will not spend so much time on this one. And another thing is you have like Docker security scanning, right? There is like a lot of things I told you about, right? You have to update and so on. And there is like, you should always check if it's good or not one, right? The images. And the Docker implemented actually inside their cloud, like hosting images, you can do the security scanning. So it's really like, it will tell you if it finds anything inside the image which is problematic. So that really helps inside. You have also like other alternatives like Docbench, like Core OSClair and so on, who are actually doing some kind of container vulnerability check. So yeah, if you are not like using these ones, and it's usually like for private repositories, and it's paid usually. So usually you have to use some kind of alternatives. I also implemented one which is called DocScan, but since this guy they actually implemented inside the cloud, there's no point. So I'm not updating it anymore, but you can actually look at DocScan, and if you find it useful, let me know, maybe we can update it and so on. But yeah, I'm not really doing any active stuff anymore on this one, if you don't find any other use, right? But it will actually look at the container and look everything what's problematic, and it will tell you, and you will get nice report. Now let's move to more interesting stuff. Of course, if you're looking at all those architectures and everything, you will see that, for example, in microservices architecture, you will have like one container for database, one container for web, one container for Redis, one container for whatever. For web server, you will see you will actually launching like 4 or 5 containers inside, right? You have to manage it somehow. Docker Compose actually helps you to actually launch so many containers and handle container dependencies, for example. So you know that, okay, for this application I need database and so on. You have like a simple like YAML file where you say, okay, I need this one, this one, this one, and then you can just run like Docker Compose up, and it will actually run all those containers up, and then you can delete them easily and so on. How it looks like, for example, it's this one. This one, for example, is from the Nextcloud, where you're actually running Nextcloud with database, web server, and so on. For those who are using actually already like the containers, can actually help me and find some problems which they see here inside this Docker Compose. Well, I'll explain to beginners like just a few basics so they know what it looks like, right? Here we'll define like web one, and we define which ports we link and so on, and you see these links, like, okay, this container links to the application. So that means it will use ports from that application to actually display the content, right? Here in database, in application, we link to the database, and then it will use those ports. So if you have if you have turned on like ICC, that means that intercontainer communication to false, it will automatically update the IP tables rules between the containers. So only those ports which are allowed here inside container, it will actually talk to the container between themselves. So any other port, they will not just go through. Anyone see any problematic part here? Come on, running only like, this is very simple YAML file. Anything problematic? Oh, we have cameraman.
Run is mounted in the container, which means you have access to the Docker daemon inside of it.
Yeah, good one. So you have like, you want Jaffa Cakes or Clubmate? You can choose.
I'll pick the mate.
Okay. And yeah, definitely. Is there any other problem? There is other problem. As you can see, I actually used some other image, like TLS1. Sorry, I couldn't like register HTTPS, right? So by combination of this image and this container of this volume, I can actually get like executing remote commands on the host. It's really quite useful, right? Here is another example. It's same Docker Compose example. I have like image, again, that problematic one, right? So I managed to register TLS1. Well, it looks secure, right? It's using TLS. And here I have, again, this one problematic line, right? It will actually mount the host from the host etc, and it will just mount, just it looks like that it's quite useful. It will link it to the, like mount it to the etc MariaDB, right? It's just some bogus directory where I will find it, so I can use it with this image. And on the end, how it looks like, I'll just show you this. Let's say I downloaded or somehow I got on the blog on someone's blog how actually run this one, and I just want to run this one. Well, it's YAML file, right? And it couldn't be, what can it go wrong, right? So let's assume that attacker runs some kind of right, netcat, so listening for remote shells, right? And let's say I'm running here, I'm victim and having like this one, like Docker Compose, right? So if I just say something like this one, oh, I just want to run this next cloud, it's perfect, right? So it will automatically run all those containers. And yeah, it's wonderful, everything is working. I'm playing with Nextcloud and whatever, right? But on the other hand, whoa, I got root shell, right? By combination of those two problematic parts, right? It's this one and this one, because I'm not using like any trusted image, and I didn't take a look at that it's mounting actually root one. I actually got like a shell, right? So that means on the host, right? I can still like list like Docker images and so on. So it's not like inside container just, right? So it's really like inside host. And yeah, I can run commands and everything, right? What I've actually done here is, let's look at this one. I have actually placed some kind of file in cron D to actually run every minute and send me like a reverse shell to my listener, right? And how it looks like inside, I can even, of course, turn it off, but it doesn't matter anymore, right? Since I actually already have the shell here. And if you look here, yeah, it's here, and I'm getting every minute shell. Of course, if I wanted to get it more stealthy, probably I would, I don't know, some kind of encode it and do things, but for demonstration purposes, it looks like this one. So I can actually now like down the container, all those containers. I can remove the shell, of course. But I want to show you what actually I've done here. Right? I have used the, yeah, thanks. I have just used the latest tag. And if you compare like Docker anti-point, yeah, I just added this file to actually append to the cronDB, and then it really worked, right? So I just got the shell via this main. So, in short, yeah, containers are quite good, for example, for forensics, as you see, because of the layered file systems, for example, in Docker. And because of, you get additional isolation if you didn't implement any, like, but comparing to virtualization, of course, you have better isolation in virtualization. And I wouldn't use, for example, containers for malware analysis, right? But for any, like, running web services and isolation between database and so on, yeah, definitely. Just watch out for those hardened Docker options and which images to choose, which Docker Compose templates as you saw. And of course, you can always harden the container itself with syscalls filtering, seccomp filtering, and of course, like you can use always selling so or AppArmor with it. Yeah, I'm finished. Thanks for listening. If you have any questions, I can answer now, or you can actually send me like Twitter message. This one is 0. So shoot. I have more to give you. Like I have clubmates, Jaffa cakes, and so on. So, any question you might have? Okay. Thank you then.